guys, welcome back to my YouTube channel. Today we are still under Fluidmechanics N6. This is the flow in pipeline. So if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video, right? Even though okay, so if you're new, just subscribe though. Okay, we have question 1. Question 1 says 1.1, define the term turbulent. We have discussed about this turbulent. What is turbulent? We have discussed about this, isn't it? 1.1, want to discuss about turbulent, right? Just what is wrong with the screen? Okay, 1.1, we're talking about the turbulent. What is turbulent? We want to define the turbulence there. They've asked turbulent flow. What is turbulent flow? And the turbulent flow must know that the particles that flow in an orderly manner, right, and occupying different relative let me write my relative nicely. Occupying relative position in a successive cross section. Call this is a turbulent flow. This is a turbulent flow, guys. This is a turbulent flow. I've discussed about this. Check my videos. Okay, particles that flow in an orderly manner and occupying different relative position in successive cross section, right? This is a turbulent flow. We are done with that. So okay, 1.1.2, they've given this summary there. It says water flows through a pipeline as shown in figure 1 below with an inside diameter. They've given inside diameter of the 150 millimeter. The rate of flow is that, and then this pipe branches into two smaller diameters, so one with an inside diameter of 50 and the other with an inside diameter of 100. So, and then if the average velocity in 50 millimeter pipe is 3 meters per second, determine the following. Okay, they've drawn for us there. So 2.2.1, here we have the structure there. 2.2.1 says determine the velocity at pipe 1. This is pipe 1 there is written here, pipe 1. You want the velocity there. Also remember, here we have given Q at velocity 1 here at 150, which is 0.02. So we know that Q is equals to what? Must be equals to area 1 multiplied by V1, because we're focusing on this first portion. Right? We want V1, they want the velocity, we make it the subject, divide by area 1 that we know is 0.02, divide this by pi over 4, Remember, then your diameter there, you divide that by 1000. This will be 0.15. You square this. Yes, you square this, or let me write here, guys. Let me write here 1.2.1. We know that V1 will simply equals to Q over area 1, whereby this was 0.02 divided by the area, whereby we know this will be 0.15 squared. Then if you punch this on a calculator, you'll get that V1 to be 1.132 meters per second. This is V1. Then now 1.2.2 says determine the discharge at pipe 2. Where is pipe 2? Here we have given pipe 2 there. So here we have the diameter, but also here we have the velocity. Say is 3 meter there. So the velocity there is 3 meters per second. So we can find the rate, because you know the rate is equals to area multiplied by the velocity. So we can attack that. So we know that the rate of change at, you can say the 1 kilowatt, they say is Q3 there, should indicate as they did there. So this is Q3, simply equals to area, remember it's pipe 2, area 2 multiplied by V2, whereby we know that the area is 4 pi d squared multiplied by V2, then pi over 4. The diameter, it was 50. This is simply 0.05. We square that, multiplied by this velocity, whereby it was 3. As we've given there, it was 3. Then we punch this. The rate of flow there will be what? Be 0.00589 cubic meters per second. So this is what we have. Then 1.2.3 says discharge at pipe 3. There is pipe 3. Pipe 3, here pipe 3. So the discharge is Q2. How can we find this? You must know that Q1 is travel. Remember that Q1 will take place like this. As this water reaches, this is the water, right? As the water reaches at this point here, the water will split this. Other water will travel at that pipe, on that pipe. Other will travel like that. But as you can see, they are coming from the same water. That means if you can say Q1, this is the Q1 from this, will be equal, remember, will split, will be the sum of the two, will be equal to Q2 plus Q3. So hopefully you understand that. So 1.2.3, 1.2.3, this is Q1 will be Q2 plus Q3. They want Q2. So Q2, if we make it the subject, will be Q1 minus Q3. Then what is Q1? It was 0.02 minus Q3, which is 0.00589. Therefore Q2 will be what? If you punch that, you're supposed to get this to be 0.0141 meters per second. So we have this meters per second cubed, meters per meters per second. Remember, it's measured in cubic meters per second. So yeah, then number 1.2.4 says the velocity at pipe 3. We are still under this pipe. We have pipe 3. We still have Q2. We have calculated Q2. So 1.2.4, we want the velocity. We know the velocity at pipe 2 will be equals to this Q. Velocity at pipe 3 will be V3 simply equals to Q2 divided by area of the diameter of pipe 3. Check, they try to confuse you with the way they've made the lettering. You see the lettering, you might make mistake, but check, they say take this as Q2, but this is a pipe 3. Check, they want you to make mistakes here. But this is Q and this diameter 3 is pipe 3, but suddenly Q2 they denoted Q, the end on the pipe 3 they denoted this by Q2. This one on the top they denoted it by Q3, but this is pipe 2. So do not make mistake there. They just want to play with you around. So there you have Q2, which is 0.0141, but the area is pi over 4 of this branch. Pipe 2, pipe 3 is 100 there, then will be 0.1, then we square, then V3 will be 1,797 right meters per second. So this is what we have. This is our final value. So guys, thank you for watching. Please subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video.